Alrighty. Does everyone have the quiz open already?
Almost.
Yeah.
Yeah, I do.
Okay. Okay, so I think I screwed this up on the last quiz that we had. Is this the 90% chance that the true mean heart rate is between 45 and 105?
We're 90% confident that it is.
Okay, because I swear I picked something like that last time and I got it wrong. But I must have picked something really wrong. Okay.
Yeah, I always just look for the word confident because it says like confidence interval. So that's
maybe
the way I like.
Things where I missed.
Where's my pencil? Oh, there it is.
Oh, and so are these the same questions that they aren't the same questions that we already answered, right? These are new questions. They're not the same questions that were in the study exam part. Never mind, probably not.
I'm gonna be honest with you. I didn't take a look at the prep.
Oh, gotcha. Well, I answered all the questions in the prep last night. They're just in Taylorsville.
Oh, yeah. See, because I did it on Tuesday, so I was like, and so when I was going to do it today, I was like, oh, I think I understand it because I already did my first look at it on accident. I think I'm going to be okay. So for question 3, I think we're on 3. I said that the distribution of the mean of each sample is normal since the data have been determined to be normal.
Yes.
That's what I got as well.
Cool.
Because they need to have the random sample, which they stated, right?
Mm-hmm.
And they looked approximately normal, which would be, you would just follow through as though they were normal, right?
Yeah, I think.
Yeah. Okay. Steve, question 4 is the one that always throws me off. I never know which one to use out of the, like, whether sigma is unknown or known, or that's what I struggle with.
Oh yeah. See, this one is kind of confused me, but there's a question like later on that has, I think it was question 18, and for that one I put C for both, and for like both of those being confidence interval for the difference of means using independent samples, and it is correct for this one.
Okay, so, and the reason for that being right is because you have 2, right? So when we were doing the known and unknown, we only had 1 sample, right?
Oh, yeah.
But in this one, we're dealing with 2 samples.
Mm-hmm.
So the reason why you know that you either need to pick independent or dependent is because you need 2 samples to decide whether or not you depend on the first one, whether whatever you pick for the first one is dependent on the second one or vice versa. Does that make sense? So like It's independent because we can measure the males and measure the females, and we don't rely on either data to come up with a difference, like weight difference. So your starting weight versus your ending weight. The first number is dependent upon the second number. Does that make sense? It's been a really long day, so
yeah, no, that makes perfect sense. I didn't understand it before you just said that.
okay.
It's awesome.
Well, I hope that helps. I can see it in my head.
So you said independent because females are not affected by the male's time?
Yeah, so you can find the mean of either and come up with a decision. But say you had a husband and a wife, and depending on whatever was going on with the husband, you wanted the number of the wife. Well, you can't mismatch wives to husbands. They're dependent on each other. Does that make sense?
Yeah, so that would be dependent, but this example is independent, right?
Correct.
Okay. Sweet. Thank you. That makes sense.
Research is interested in estimating the savings account balance of customers and all our should change the savings account balance of customers.
So I got B for this one, but I'm not 100% sure.
I was thinking that one too.
I got attained a balance of 90 bank customers rather than 30.
Yes.
Because when you have a larger sample size, you can be more confident.
Yes. I'm going to side with Ruth.
So the last one?
So, but why is it
Also, it's
not
right.
a high confidence interval? Does that make it smaller?
I'm just following just the general idea that the larger your sample size, like she said, the more confidence you can have that it's going to. I don't know how to explain it. I know the book says it a lot better.
Which of the following produce a confidence interval with a smaller margin of error? Well, yeah, just because it's then like your 95% confidence level. Because you're talking about margin of error instead of your just confidence interval. Like I feel like if you just change your 99% confidence interval, like you're not really doing much of a difference because you still have like I know that they say that 30 does count, is like 30 is your line of when your sample size becomes large, but when you make your size larger, your sample becomes more accurate to the population that you're like looking for. And so when you do 90 bank customers instead of 30, you have a smaller margin of error because you are getting your it's remember in the beginning when we said when you roll a dice, like the more you roll a dice, the closer your percentages get to be 1/6 for each, because that's how it should be, because it's a fair dice. Well, it's the more people you get in a survey or in your little thing that you're doing, is like the bigger number you get, like more people you involve, the closer you have to it being an accurate representation, which would decrease your margin of error.
Gotcha.
That does make really good sense.
For number 6 is kind of, for that one is like one of the numbers that they use all the time for 95% confidence interval.
1.96.
Yeah.
Isn't the margin of error also 1.96 because the standard deviation is 2 and the sample size is 4? So you do the square root of 4 is 2. So 2 divided by 2 is 1. 1 times 1.96 is just 1.96, right? Or
Yeah. No, that's right. That's right.
Oh, I'm so bummed. These sound so much like the questions that they had in the preparation.
Then they might be the same one.
because that's what they did for the last exam. They had a lot of the same questions, but then they added like 1 or 2 new ones. But then they just placed everything like out of order.
Okay, so obviously that's the 1,000 minus 1.96. So the lower is 998.04.
Yeah, that's what I got. Which gives me for question 8, I got 1,001.96.
Okay, so do you guys remember what the formula is for that?
Yeah, it's n equals the z-score times standard deviation divided by the margin of error, and then all of that is squared.
Oh, yes, I remember this.
So I got 1.96 times 0.01 divided by 0.0001 squared. And all right, let me just do it one more time, just because I got 38,416. If that sounds right, let me just do it one more time.
That's
I know it's right, but I know it's right, but it's just I want to do the math again. If that makes sense.
That is a big number, but then again, our 1,000 was pretty big before.
We were also dividing it by 0.0001.
Yeah.
Yeah.
Did you say 38,416? Is that what you said?
Yeah.
Okay. That's a really big sample size.
But I guess that makes sense though, because it would have to be a really big sample size to have a really small margin of error.
Right. No, that makes perfect sense.
Yeah, because you have to do 196 squared.
Mm-hmm.
For question 10, I got D.
That's
Yeah,
what I got as
the
well.
left-tailed one, right?
Yes.
Yep, I got that too.
And for 11, I got B.
That's what I got too.
Yeah. For 12, I got C.
That's what I got too. I wasn't sure on that one, but that's what I thought it was.
Which one did you get?
D?
C for 12?
That's what I got, but I wasn't sure.
Can they use an ANOVA hypothesis? Okay, when I did this yesterday, it really confused me just because the ANOVAs, I just remember something about the ANOVAs being like using the F, instead of the Z or the T, they use the F, and that it's right skewed. And so I got a little confused on that.
I think that one, it's just you have to have a test, and the first test is if it's normally distributed, and the second test if the variances are equal.
Okay, that helps.
And so I think because this is saying it's bell-shaped with no outliers, it's saying it's normal, and then it's saying the variances are equal. So then. And so I think the answer is yes, for sure. But then, isn't the central limit theorem? It's probably a dumb question because I remember we learned it like forever ago. But that's just meaning that we can use a normal test because it is normal, right?
I thought that was referring to, I get them confused, one or the other, where if the sample size is larger, then it's closer to the mean. And what is the other one? What is the?
Wait.
Yeah, central limit theorem is when there's a large, I think it's when there's a large number, it's normal.
Wait, I have a question.
A large sample size?
Yeah.
Why is it not C?
It is.
Yeah.
What?
It is.
Oh, I thought you said it was D.
No.
So I was like, why is it not C? Okay, that was what was confusing me. Thank you, guys. Alrighty.
In 13, I thought it was B.
I got A.
Sweet. You're probably right.
Which one was which again? The type 1 error.
Type 1 is when you reject the null, but the null is actually true. And type 2 is when you fail to reject a null, but the null is actually false. So if it's saying yeah, type 1 is what I'm getting.
That makes more sense now that you say it. I don't think of all those things at first.
So then if you reduce the probability of committing a type 1 error, then that increases your probability of committing a type 2 error, right?
Yep.
Yeah.
Did you say that already?
A for 14?
Yes.
Yeah, that's what I'm getting.
Yeah.
I have to go get my water bottle, but I'll be back in like 2 seconds. But for question 15, I got D.
Sounds good to me.
Right. And that's because the mean is larger than right? The 1.5, because it's larger, we would reject the null hypothesis.
Something about milking pizza makes me happy.
Yeah, that sounds right.
Sorry, I'm back. What?
We just started 16.
Oh, 16?
Yeah, you looked at
16, I got B.
Yes, and that's the one we were, oh no, never mind. But it's the same thing, right? The independent samples t-test. Because there are male and female students, so there's more than one sample, but not more than two. And the paired sample t-test is when they rely on each other, it's when they're dependent.
Yeah.
I'm gonna write this down. So wait, so ANOVA is what you use
For like 3 or more.
3 or more. One sample z-test is like the very first one that we learned, right?
Yeah.
And then how can you tell if you need to use that or a one sample t-test? I always get those confused. Oh, that's when z-test is when standard deviation is known, right?
Yep,
And t-test is when it's unknown.
yep.
Oh, okay. Saying it out loud is making it easier. The independent and the paired are both just 2.
Yep.
But we already talked to each other about the difference between those 2. Okay. Okay, cool.
Which goes into the next question, the independent or dependent sampling. So because she's pairing the brothers and sisters together, she can't have one sample without connecting it to the other sample. So they're dependent on each other. So it'd be dependent sampling for sure.
I put D.
Yeah, that's what I got.
Number 4. Sorry. B and D sound similar, but D as in dog.
Gotcha.
Yeah.
We're more than halfway done, guys.
Yay.
Just trying to open up that Excel sheet.
So I think I was having some trouble with this one. So would it be A when O is unknown? Because we weren't given the standard deviation. Because normally they would just give you the standard deviation in your question and it would be known, where in most cases it's not.
But I wonder if you put it in if it gives you that. Wait.
Well, I think the spreadsheet will work it out for you, but technically speaking, they didn't give us the standard deviation. They just gave us the sample information. Does that make sense? Am I overcomplicating this?
Oh no, you're right. We only have the sample standard deviation, whereas they're talking about the big picture standard deviation is unknown. So you're right.
So the A, right?
That's what I'm thinking.
I got.
Okay. Sorry, I just have to work through it and make it make sense out loud.
Well, it makes it easier for me to understand, so thank you.
Okay, remind me how we come up with the margin of error again.
So it's a 95% confidence interval. So you have your 1.96. Sorry. Times something over the square root of Jewel. What do you have it? Because I wrote it down, but I forget what exactly.
Wait, what?
The margin of error.
Oh, the margin of error is the z-score times the standard deviation over the square root of n. But when it's the
Okay.
t-score, it's I think you switch it out.
It's x plus or minus? No.
Oh, I thought you were just talking about margin of error. X,
Yeah.
the mean plus or
Margin of error
minus.
is z times standard deviation over square root of n. Yeah.
Okay.
But I believe that with the t-score, you switch out. Let me double check. Oh no, you're right. So the t-score is the mean, the like sample mean
Mm-hmm.
minus. Oh wait, that's not margin of error though. Okay, wait, I found it. Yeah, it's just t-score instead of z-score. It's t-score times this standard deviation divided by square root of n. And I'm assuming that since the standard deviation is unknown, you use the sample standard deviation that they give you. I'm pretty sure.
Yeah, because your z-score is, your margin of error is your z-score times the square root over the square root of n. And then I guess if you want to find your n, you'd like reverse it kind of. You do your z-score times your standard deviation over your margin of error, and then have that all squared together.
Okay.
Now, we don't have to change the null hypothesis or the type of test just yet because that doesn't ruin the confidence interval, right?
Nope, it doesn't change it. So what did you guys get for the margin of error?
So the margin of error I got, 1 second.
I got 2.025.
Oh, I really messed that up. Okay, so
Around the same thing, 2.024, but that's because I cheated and did my upper bound minus my mean. But yeah.
okay, so wait, where does the mean fall into place? I thought it was the z-score times the standard deviation divided by the square root of your sample size.
Right, but usually how you find your lower and upper bounds, so this is why I'm saying I cheated. Usually you find your lower and upper bounds by plus or minusing
Right?
margin of error from your mean.
Okay.
So instead of doing the margin of error formula, I just took my upper bound and I minus my mean from it to get my margin. But that might confuse you more, so just ignore that. It's probably best to do the formula.
Okay, so what? But I still got a different answer. I apologize. I must have done my math wrong. So what did you come up with?
I got 2.025.
Okay. So do I have this right in my spreadsheet then? Is your t-score 3.301?
Oh no.
I got my t-score to be. Here, let me make sure. I just pasted.
I got 13.69. 13.639.
Okay, so I must have put the wrong. I make myself crazy. Oh, do I need to have something in the... Oh, I had a 10 in my null hypothesis. No wonder.
They have a t-score of 5.652.
Oh my goodness. Okay, so what happened?
But we don't need to look at the t-score now. I think it has to do with what your null hypothesis is. So if you put in a 0 and you do like not equal to, it's 13.639. Yeah. But right now we're not really needing that. Because yeah, if I have 10 there, then it's 3.301. Oh, I guess that does make a difference, huh? What you get.
It changes your p-value.
What?
It changes your p-value.
Yeah, it also, depending on what you have in your null, it changes your t-score as well. So yeah, I just did it from taking the like upper bound and minusing the mean, or to check if you get the right thing, then you could take your mean and minus the lower bound. Or...
So are you saying like the confidence interval?
Yeah, that's your lower and higher bound.
Okay, so I see what you're saying. That's where I think that's where I'm getting this. I was making things much too complicated is what I was doing. I'm so sorry.
Okay. Oh, you're good.
Okay, sorry. I'm not going to hold this up anymore. I'm on the same page. So obviously the lower is the 11.168.
Yes.
Sorry, you guys have probably already all passed me.
I am not. I'm just these type of questions I'm not 100% on, so I'm gotta study up some more before the test.
Well, do you want us to share our screen and show you kind of what we're doing?
No, you're good. I might catch it on. I just am not 100% confident in all of it.
Well, so all we were doing is going over to that Excel spreadsheet that we have that has it's the I don't know if I'm saying it right. Is it quantitative inference procedures? You know what I'm talking about?
Yeah.
It has the one sample t-test on the bottom. That's where we put all of our samples in, and it gave us our t-score and our confidence interval. The confidence interval is from the bottom to the top. So the lowest number that it could be and the highest number that it could be.
Yeah.
Does that help at all? Or am I
Oh, yeah, that does.
Okay.
Thank you.
The Excel spreadsheets are amazing.
Oh, yeah.
I really did all this stuff. If it's the same numbers, I did all this last night. I'm kicking myself. Okay, so this is going to be our paired sample t-test, right? Because we need to know the difference between the Hummers, or no? Oh, no, we don't. We need to do, is this a two sample t-test?
I thought it was, but
I think so too.
I'm doubting myself now.
I think I overthought this one last night, but I think it was the two sample t-test.
Wait, I think I need to reread this question. So that's independent, right?
Yes.
Alright, I messed up and I accidentally put all of the Hummers prices.
I almost did the same exact thing. It's not a very short list either. Holy moly.
Okay, I gotta read it. Let's see.
Okay, guys, I think I need to leave a little early. It's a little past my 20-ish minute mark, but it's been real. Thank you for your help.
All
Well,
right.
thanks for joining us.
Yep,
Yeah.
and we'll see you next Tuesday. Thank you.
Good.
Oh my god. Okay. Okay, so we said independent for that.
So yeah, for 22, I get C because they're independent samples.
For your lower and higher bound, you got negative $423, or not dollars, but 23, or yeah, dollars, whatever. 0.238, right? And then for the higher, it's 5,417.336. Is that what you guys got?
Yep.
5,417. Yeah.
Great.
Ugh. Sometimes when I'm trying to like slide down with my laptop, I'll get this notification saying that I don't have permission to print the page. I'm just like, I'm not
I
trying to
do
print the page.
all the time. Haven't you guys heard me say that? I'm not trying to print the page. So you could answer that next question without actually inputting anything, because it's talking about 3 different things: a high jump, a low jump, and no jumping. So we already know we have 3 groups of data, right?
Yeah. So A
Which
no
would
goes.
require, yep.
Yay. Guys, we're so smart.
Look at us.
Some of this stuff is sticking.
I feel like it sticks more after I meet with you guys.
It does. I don't know what I would do without you guys, because some of this stuff is like, what? And then you say it, and I'm like, oh yeah, that makes perfect sense.
I can see how that's a thing.
But when I do it by myself, it's ugly.
I feel the same way. Okay, right now I'm just copying and pasting everything.
Same. In fact, I think I had all of these in here already from last night.
One more.
The variances, I get them all equal because the highest one is not greater than 4 times the smaller one, right? That's how you know that the variances are equal.
4 times the smaller one. The highest one has to be 4 times the smallest one.
is less than 4 times the smallest. Yeah.
Cool.
Wait, what question was that?
Oh, it
What did I
wasn't,
miss?
but I was just.
Oh, okay, good.
For question 26, I got 7.978.
Hmm.
Wait.
And for the p-value, I got 0.002 because we're rounding it.
Yep.
Cool. Let's go a little more. But the p-value is definitely less than 0.05.
So I found my personal trick. Can I just share this with you?
Yes.
So I have to relate things to like kind of how you were talking, Jewel, about this before, how you have your own little way to relate it. If I say A is smaller, then I'm thinking the lower end of the alphabet. It's smaller, so I reject it, therefore it's efficient.
I like it.
So if it's greater, right? If it's greater, then I fail to reject.
It's closer to F.
Yep, it's G, F, and I. And then it's insufficient.
I like that. I'm probably going to use that.
Now I won't forget.
I need to backtrack.
Yes.
Question 26. It's asking for the T statistic. How do you find that? Do you just find it with you type in the p-value?
Nope, it's simple. Instead of, remember how we were talking about Z, T, and F score?
Yeah.
Because you're in the ANOVA, it's the F. So
F is the same thing as the T score?
Yep.
Well, yeah, when you're in.
Okay, so I got 7.978, right?
Yeah.
Okay.
So I'm sorry, I won't bore you with my.
No, I like that. I'm actually, for real, I'm going to use that.
So D for question 28, I think. Was it? Yeah. 28. Sufficient evidence to conclude that the mean bone density of at least one of the groups is different from the mean bone density of at least one of the other groups.
Yes.
Wait. Sorry, for 27, you're rounding to 3 decimal places, right? So you did 0.002?
Yeah.
Yep.
Okay. So because they are the same variant. And also, I have another dumb question. But how are you guys making your QQ plots? Because I have tried every single graph in Excel and I'm not able to make them.
So go back to your other sheet, not your inference procedures Excel sheet, but instead use, I have this up, I do. I just have to find it. Oh, it's your descriptive statistics. Do you remember that first Excel spreadsheet you were using that had the histograms and stuff on it?
I think so, but it's all a matter of if I still have it saved. I should. Why would I not?
Yeah, it should be in your recents because if you change anything to it, it will save it for like forever.
Yeah, I'm wondering because I have the categorical data analysis and the quantitative inference procedures and but
I think it's quantitative descriptive, right? Yeah.
oh, there it is.
It's down at the bottom.
QQ plots, second section.
Okay, I think it's still opening. Thank you. That helps. But anyway, sorry, 28. What did you get again?
D.
There's sufficient.
D out of E.
And then don't forget when you do your QQ plots, it says right on it, but it took me a minute. Just make sure that you sort it from smallest to largest. Otherwise, your little dots are all over the place, and it will all look like it's not normal.
So you guys said the sufficient evidence to conclude that the mean bone density of at least one of the groups is different. From the mean bone density. Is this because it wasn't normal? Or, oh, no. Wait. That's because, what was the
So-
test that
So you did the A equals whatever it was, right? 0.05. And our answer was 0.02, so it was smaller.
Oh, okay.
So we rejected it. So we said there was sufficient evidence. And then you have to read the end of it. So there wasn't sufficient evidence to say that all of the groups are different. We don't have that much information, right?
Mm-hmm.
I just remember the verbiage one, at least one of the other groups. So at least one of the groups is different from the mean bone density of at least another one of the groups. At least one of the groups. Is that?
No, that makes sense. I always forget that it's similar to what we learned in the past. You just tie it back because it's like worded a little different.
It makes me think way too hard.
So, question though.
Yes.
So back to the QQ plot thing. So you put in, can someone like share their screen of how they put it in? Because there's only one column. Do you put all three categories into the one column?
I have it up, so let me grab it. My screen's a mess, but I will show you.
Thank you.
Okay, so what was your question? Oh, you have to do QQ plots for each one of them.
Oh, individually.
Yes.
And they all have to be normal for it to be normal, right?
Yes.
All three of them. Okay.
Do you want me to still share my screen?
Actually, yes. Because you have to put it in like from lowest to highest, or is there a way that you could tell Excel to do that for you?
I'm
You
pretty sure you
can
can tell
tell.
Excel to do it, but like I'm just trying to find out
I'll
and
show
do it
you.
again.
I'll show
I
you.
think it's sort and filter.
Yep, it's
Smallest to largest.
Can you still show me? Thank you.
my screen a mess now. Can you see me?
Yes.
Okay, so I just highlighted it.
Okay.
Right click. Here's your sort from smallest to largest.
Oh, I like it. Thank you. That helps a lot.
You're
I
welcome.
do have that Excel sheet.
I had to Google that. I'm like, what am I doing wrong? I don't understand. And the directions are right here. But hey, I won't ever forget, that's for sure.
I'm just gonna do it just to. Let's see.
Wow, my brain is just, I am not here. Okay. Okay, so we need to take the data from 14 days and compare it to the data of the 90 days, and we need the difference of the two, right?
Oh, what we could do is if we, because I have it up already for what could make it like really simple, is I have it up for the, which one is it? The second one, which is, have it for the 90-day one up already. And what I can do is if we each show the graph that we got, so like I do 90, someone do 14, and someone do the difference, and I can compare all of them.
Okay.
What are we doing? The QQ?
Yeah.
Do
But
we
first, let me.
Do we have to do a hypothesis test to determine if there's a difference in the mean? I don't think we have to do the QQ plots, do we? I think we just need to use the red test, which would be the dependent samples.
Yeah.
Yeah, because there's only 2 of them. There's not 3 or more.
So then I put this over in Excel. Make sure when you do, there are a few that you're missing all the data for.
Yeah.
So you make sure you take those out because you can't compare the two. Yours will get all up. Does that make sense?
Oh, so you take it out for the other day too?
Yes. You have to make sure you have both. So because the computer will understand it as, oh, your ticket was $184, but it won't compute the difference because there's nothing to subtract it from. Does that make sense?
Yeah.
So take all those out. You should be missing 3. You should have 3 completely blank spots.
1, 2, 3. Yeah.
Okay.
So I'm sorry. So you're doing a 2 sample because it's independent?
I'm doing a paired sample t-test.
Oh, so it is dependent.
Yes.
So for 30, I got 1.685.
I have 1.684. Is that the
So
T?
you're doing 1 at a time. So you're putting in 14 or 90 days or.
I'll show you.
Sorry.
No, you're good.
Again.
Like I said, I had the benefit of doing this already last night, so this was helpful for me.
Okay.
Okay. So here's your paired sample t-tests, right?
Yeah.
So this is my 14 days.
Okay.
Right here, this is my 90 days. So then I went into Excel and I said this, do you know Excel very well?
I did take an Excel class a couple semesters ago, but I don't remember much. So
I just made sure that I said this box equals this minus this, right? That way you're making sure you're subtracting one side from the other. And then once I had these 2 done, I just drug it the whole way down.
And it copies the same formula.
Yeah, so as long as you do those first two boxes, if you highlight them like this and then get your little crosshairs in black and pull them down, it will take that formula the whole way down.
Oh, I like it. Thank you.
I'm a big fan of tricks, so if I can share, I'm happy to.
Okay, so copy and paste that there.
So, and then this is what I was talking about. So when you put your information in the first time, one of these boxes had a number in it. So let's just say I have another 180, 85, whatever here. It changes my number, which changes my t-score. But I didn't have anything over here to subtract it from. So I took it out because it's not reliable information. Does that make sense?
Yeah, I got, for my test statistic, I got 1.685.
I hope I didn't screw something up.
No, I think it's, I don't see anything wrong with either answer. But for your p-value, did you get 0.952?
Oh, now I have 0.09. I may have to double check how I copied and pasted. Make sure. Okay, let me see. You're probably right. I probably just pasted something wrong.
No, I don't know, because they're kind of close enough, so maybe we just have it set up to be different. Because you know how sometimes if you don't have it set up to like release a certain amount of decimal places, it'll round it from there.
Oh, yes.
So we probably I feel like we got the same answer, we just have like different like decimal places. And I think both of us are technically right.
Well, but I also have a bad habit of like missing the small details. Okay, so
I'm way behind. I'm still trying to copy and paste, sorry. But for your so for your null hypothesis, did you change anything or no? Because sorry, I'm still on the T statistic one because I was still trying to do the equal like yeah. So for my T statistic, I got 1.636. Is that right?
I got 1.685.
Yeah, I think that's right. So did you take out those? Do you have 3 missing spots?
No. So when it's missing from one of them,
then take out the other one.
Okay. So they have to be missing on both.
Yep.
I think this is what I got wrong on the couple. This one I took.
So if you're thinking of it like, so it's your dependent. You depend on one to have the other. So say you were tracking your weight loss, and one day you recorded that you weighed 130, and then the next week you weighed 135, but you forgot to record the 130. You can't record the 135 because it will throw off all your numbers.
Gotcha. Okay, that's definitely what I messed up on. So you got 1.684?
Ruth got 1.685, and I tend to trust her more than me.
Okay, I don't know what I'm getting wrong. Did you guys take out the zeros completely, or you just leave them as zeros, or?
Oh, do you know what? I think you have to do a blank.
Oh,
I left them as blank. I just deleted that information.
Okay, let's see, I can't. Okay, 1.685.
So those are zeros. You're right. How does that happen? That's funny. Okay. Hey, thanks. Now I know what I was doing wrong because that was making me crazy.
Okay, so for the p-value, you got 0.096, right?
Yes.
No.
What?
Oh my god.
No, like you guys are probably right. I'm just really confused right now because I got my p-value. I got 0.952.
I have 0.096.
Wait, what's your type of test?
Oh, wait, one sec. Excel just shut down.
How rude.
I don't know.
What test is it supposed to be? Because that changes things.
The paired sample t-test.
Yeah, that's what I was on.
mean, like type of test, not equal to, less than, greater than. That one, yeah.
I did not equal to.
That's what I have. What is it not supposed to be not equal to? Wait, what's the question?
It's not opening what I want.
It just says, yeah, determine if there's a difference, so it should be not equal to.
Yeah, it should be two-tailed. I guess maybe I didn't get that. One sec. It's really having issues right now.
So I'm sticking with the 0.096. I'm pretty confident about that one.
And Ruth, I swear that that's what you told me you had the first time, because I said I had 0.095 and you said you had 0.096. So maybe you might have just clicked in something and it changed your answers, but I swear that's what you said to me.
Yeah, okay, just kidding. Yeah, it changed. Because I guess when I was trying to figure stuff out and like see like maybe if I like put it something in wrong, I changed it from not equal to less than.
There you go.
So yeah, 0.0956, but to 3.096.
Yes. Awesome.
Cool.
So there's insufficient evidence to conclude that there's no difference in the mean cost of tickets purchased 14 days in advance compared to 90 days in advance, correct?
No.
I got
So same. So remember we were talking about, okay, so 0.096 is smaller
Okay.
than 0.10. So if it's smaller, then you reject the null and there's sufficient evidence.
Fine.
So this is where I get a little bit confused. Is sufficient evidence? I have to really think about that there's a difference in the mean cost.
But there is a difference.
Uh-huh.
Sufficient evidence. Okay. Sufficient evidence to conclude that there is a difference because we're rejecting the null. Gotcha.
Right? That's what
I
makes
got
sense.
B the second time.
Yeah, that's what I got.
Yay.
Alrighty. I do have to head out like right away, so I'm hoping everything's right.
I'll tell you what, I'm gonna make sure that I have my little binder with me everywhere I go. Will not leave that at work again.
Sorry you had to redo it all.
No, it's good.
30.
It sticks, you know. It's good. 100%. Yes.
Yay, everyone got 100. I do have to go. I'm sorry to cut you out short. Thank you for starting the video, Heather. I appreciate it.
Oh, no problem. I will go ahead and post this and send you a text.
Okay,
So-
thank you both for helping so much. I'll see you guys Tuesday.
I'll see you Tuesday.
Have a good evening.
Oh, you
Bye.
too. Bye.
Bye.